Okay, now we're going to take a look at our ground detect lab where we use ground detect lights and understand the principle of why that works. And so what I have here is I have a relay here that I'm going to use as the load that I would want to be working normally, and then I'm going to have a light here that would be a ground detect light. Okay, so the first thing I'm going to do is I'm going to go ahead, I'm going to get the resistance for each of these. Okay, so if I come here and I go the resistance of the light, and I'm going to get the resistance of the relay. Okay, so if I bring my meter in right here and I set it to ohms, and I set it up like that, I can come here and I can get the resistance of the light. Sorry, let's set that to resistance. I've got, looks like 1236 ohms. So the resistance of the light, 1236 ohms. Okay, let's go ahead and do the relay. Remember the relay, the coil is 17 and 18, is the coil. So if I come right here and I get the resistance of this, I get it at, looks like about 78.7 ohms. 78.7 ohms. Okay, so the ground detect works because somehow there's a short, a fault, and the two loads get put in series by accident. So if I had that situation here where I had my red light and somehow I got that in series with my control relay, well, the question is what would happen? And I'm going to use Ohm's Law to figure this out. And remember, Ohm's Law is for DC circuits. These are AC. There's some induction involved here. And so this isn't exactly 100%, but this is going to kind of, it'll approximate it, and it's going to give you an idea of what's going on here. So we know that our light here was 1,236 ohms, and I'm just going to make this about 79 ohms, okay? So when they go in series, the total resistance is the sum of those, 1236 plus 79. So I bring my calculator in here. I can go 1236 plus 79 equals 1,315 ohms. Okay, I can get my current, I equals V over R. In this case, I'm going to be hooking up to my voltage source again, which is 120 volts. So I'm looking at 120 volts over 1,315 ohms. So 120 divided by, what was it, 1,315. I'm going to get 0.09 amps. We'll just go with 0.09 amps flowing through this circuit right here. Okay. Now, what does that mean? Well, because this is series, we know that the current stays the same. So whatever current comes through this one is the current that comes out of it and goes into this one and comes out and returns to the source. So 0.09 amps. Well, we can get our voltage drop for each one of these. So V is equal to I times R. Okay. So if I take my first one here, my current stays the same at 0.09 amps times 1,236 ohms times 1,236. I'm going to get 112. I'm just going to go ahead and, for purposes, round it up to 113 volts. Okay. Okay. And so what does that mean? Well, that means that this 120 volt drop, we can do the math where we go 0.09 times the resistance of this one, which is 79, is about 7 volts. So the other voltage drop for the control relay is about 7 volts, and that makes sense, 113 and 7. So I have 120 volts across here, like I said. This is going to drop 113, and this is going to drop 7. So if I were to build this circuit and somehow there was a short and they ended up in series, what is going to happen? Well, let's just do it real quick. Apparently coming out of my voltage source here, I'm going to my red light. Coming out of my red light, I'm going to my control relay. And then coming out of my control relay, I'm going back to my source. So I go ahead and bring my power on. You see that this light comes on, and it's pretty bright because this light normally has 115 volts in it, right? And then the relay right here is not coming on because of the way the resistance here, it's only dropping 7 volts. And there's no way that a relay that has a 120 volt coil is going to come on if it has 7 volts coming to it. Okay, so that's the premise of how the circuit works. Now I'm going to go ahead and I'm going to take that this relay off right here, and I'm going to replace it by another light right here. So that's our dual ground detection lights. So this is a case where you're going to see that these should have essentially the same resistance, and therefore when they, instead of having one that's much larger and one much smaller, then the voltage drop, if they're the same, should be equal instead of having one drop a significant amount of voltage. So the voltage drop should be the same. And so when I go ahead and turn them on, you'll see that these are on. They're just barely on. They're on really lightly. I shut it. You can see they just barely come on because each one's getting 60 volts instead of 120 volts. So as we work through the ground detection circuit, you want to keep in mind, what makes for a dim light and what makes for a bright light, and how come the load's not coming on, but the light is bright, and are they in series, and is there a short? But this math right here is the premise of how the lab works.